Hello, Professor. This is Kura Jagadishwar Gaud, following my teammates Arti Reddy Gujula and Pranusha Gandra. Now I am going to give a presentation on keyword extraction. Keyword extraction is a method used to automatically find the most important words or phrases in a piece of text. The goal is to quickly capture the main ideas without having to read everything. Imagine reading a long article and picking out just the key terms that summarize the content. This process often uses computer programs that rely on specific rules or algorithms to detect which words are used frequently or seem important. It's a big part of natural language processing. Natural language processing is a field in machine learning and artificial intelligence that helps computers understand human language. In simple terms, keyword extraction helps computers quickly find out what a text is about by identifying its own words. Coming to the next slide, in what context would you use it? In areas like text mining, information retrieval, and natural language processing, summarizing text is an important but challenging task. It has many uses like figuring out the topic of document or creating automatic summaries. And a key part of a process, keyword extraction, this technique helps by quickly finding the main words or phrases that outstand in the document. For example, if you have a thousands of online articles, keyword extraction can automatically pick out the important terms in each one, saving a lot of time and effort. This process allows Steam to identify the large amount of text much faster. Next, we'll explore the most common method for automated keyword extraction. Coming to the next slide, but why would we require these methods? Keyword extraction helps in three main ways: save time, find relevant documents, support machine learning. Uh, Save time. Keywords give a quick summary, helping users decide if a document is worth reading. Finding relevant documents. With so many articles available, keyword extraction helps locate the most relevant ones. Supporting machine learning. Keyword helps machine learning algorithms understand and categorize content more effectively. In short, keyword extraction saves time, helps find relevant content, as well as it support machine learning. So going to the next slide, approach methods. To extract keywords, we use supervised and unsupervised methods. Supervised methods require labeled data, which makes them accurate but harder to use since labeled data isn't always available. Unsupervised methods don't need labeled data, making them versatile and widely used across different areas. Unsupervised techniques come in three main types: statisticals, graph based, and embedding based. Using word frequency, statistical method works. So, in graph based techniques, it creates words networks, example text string. In embedded based techniques, uses words meaning with machine learning. In short, unsupervised method helps us find keywords automatically, even label data isn't available. So going to the next slide, my teammate Pranusha will explain it.
Hi, Professor. I'm Pranusha Ganra. I'm going to discuss about statistical methods. Statistical methods such as TF-IDF, that is term frequency inverse document frequency, and YAKE, yet another keyword extractor. They are the essential tools for identifying significant keywords and phrases in text. These methods analyze the frequency and distribution of words within a document, allowing them to highlight terms that are statistically significant without requiring additional contextual information. They may miss important keywords or phrases, which are contextually relevant but appear infrequently in the text. This can lead to the omission of terms that, while not statistically prominent, holding significant meaning within the context of the document. Thus, statistical models are valuable for keyword extraction. They may not fully capture the richness of the text meaning. Next slide, please. TF-IDF. TF-IDF defines term frequency inverse document frequency It is a statistical measure used to evaluate the importance of a word within a document relative to the collection of documents. It combines two key components, term frequency, TF. This measures how often a word appears in a specific document. Inverse document frequency, IDF. This component assesses how unique or rare a word is across the entire corpus. The final TF-IDF score is calculated by multiplying the term frequency by the inverse document frequency. As a result, words that are significant within a document but not common across the whole corpus will have high TF-IDF scores, indicating their relevance. Conversely, common words that appear in many documents will have low scores as they contribute less to the unique meaning of any single document. Next slide. Coming towards the slide, the above equation represents the term frequency inverse document frequency TF-IDF score. It is a statistic used in natural language processing, information retrieval, and text mining to measure the importance of a term within a document relative to the collection of documents. In this equation, T represents the term which we are examining. This formula is used to assess each term. This metric helps highlights the words that are unique to specific documents rather than commonly found across all documents. Next slide. YEK. YEK stands for Yet Another Keyword Extractor. It is a keyword extraction tool that utilizes a five-step process to identify relevant keywords from single text document without needing a large data set. Text pre-processing. The input text is cleaned and prepared by removing stop words, punctuation, and other irrelevant elements. Coming towards n-grams generation, the clean text is analyzed to create n-grams, which can be single words or combination of words. Each n-gram candidate is assigned a score based on several factors, including frequency, degree of occurrence, and position within the text. The scores of the candidates are normalized to ensure consistency and comparability among different candidates. Finally, the top scoring n-grams are selected as the keywords, providing a concise representation of the most relevant terms in the text. It uses a five-step technique to extract the keywords. Next slide. Coming towards graph-based methods. Graph-based methods for text analysis involve representing relationships between phrases or words in a text as a graph, where nodes represent the phrases and edges represent the connections based on their co-occurrence or contextual relationships. These methods leverage the structure of the graph to evaluate the importance or relevance of each phrase within the context of the text. Next slide, please. Text rank. Text rank specifically is an adaptation of the PageRank algorithm used in web search engines. It ranks phrases based on their connectivity within the graph, allowing for the identification of key terms or concepts in the text. This method is very useful in various applications such as keyword extraction, summarization, and topic detection, as it highlights the most relevant information based on the relationships between phrases. In summary, TextRank is powerful due to its simplicity, versatility, and ability to handle different natural language processing tasks without the need for training data, making it a widely used technique in text processing. Rest of the slides will be continued by my friend Aarti Reddy.
Hello, this is Aarti Reddy and I'm going to present from this slide. So now coming to the slide, stages in the text rank. Text rank is an unsupervised graph-based algorithm for extracting key phrases and summarizing this text. So stages in text rank. We discuss about articles. The input is typically a long document or multiple documents which needs to be summarized. Text. Here, the text will be processing and the text is divided into sentences where stop words, punctuation and unnecessary symbols are removed. Now we discuss about sentences. Each sentence is converted into a numerical representation, typically by using word embeddings or simpler techniques like TF, IDF. So next, sentence vectors. So here, this results in sentence vectors that capture the semantic content of each sentence. Now we discuss about similarity matrix. A similarity matrix is constructed where each cell represents the similarity score between pair of sentence vectors. Here, the cosine similarity is commonly used. Next is graph representation. So here, each sentence becomes a node and edges between nodes, which represents the similarity between the sentences. So here, only pairs with similarity scores have the certain thresholds which are connected, which are being formed a weighted and undirected graphs. Uh, it is being transformed to sentence ranking. So here, text rank applies the page rank algorithm to rank nodes based on the edge weights. So here, sentences that are central or have strong connections to other sentences will have higher ranks. Now we discuss about summary. Um, so here, sentences with the highest ranks are selected to create a concise summary. This pipeline is effectively because it uses the both sentence similarity and graph-based ranking to identify the most representative sentences, leading to a coherent and informative summary. Now going to the next slide, rake. So rake is an algorithm used in natural language processing to quickly extract keywords or key phrases from a document without needing any prior knowledge or training data. So it was introduced by Swet Rose, Dave Engel, and Nick Kramer and Wendy Cowley in 2010 in their paper titled as Automatic Keyword Extraction from Individual Documents. So here, the rake algorithm operates by breaking down text into separate words or phrases, referred to as candidate keywords. So these candidates are then ranked and scored based on their relevance using the specific rules of thumb to determine which terms are the most significant within the text. So these makes the rake a simpler one, yet effective and technique for the keyword extraction. Especially, it is useful when processing the individual documents. Now we discuss about the next slide. It is stages of rake. Uh, Candidate keyword extraction. So here, the rake begins by splitting the text into phrases, where treating each contiguous sequence of words separated by stop words, like and, the, of, as a candidate keyword. So here, each candidate keyword may be a single word or it may be a multi-word. As long as it is uninterrupted by stop words. Then we discuss then going on to the graph construction. So while the original rake does not construct a graph, so the algorithm co-occurrence calculations will be implicitly form a network with the connected words. So here some variations of rake involves creating an explicit graph of word connections for more sophisticated analysis. By word scoring, then now we discuss about candidate keyword scoring. So here each candidate keyword is scored based on the individual word scores. So which are being calculated using TF like term frequency and word co-occurrence. A word score is computed by dividing sum of its degree by its frequency in the text. Being transferred to keyword extraction. Finally, the candidate keys are ranked by their scores, and the top rank keywords are selected as the most relevant terms in the document. So these extracted keywords are the output, offering insight into the document's main topic or themes. Now coming to the next slide, application of keyword extraction. So context tagging. So here keywords help organize the documents by assigning the tags for easy categorization and relevant context suggestion. Now we discuss about entity recognition. So here it recognizes like specific names, places or events in text by using keywords, enabling better information extraction. Now we discuss about topic modeling. So topic modeling here is grouping similar documents or identifies hidden themes by creating or treating keywords as document features. Now, SEO, search engine optimization. So here it uses the relevant keywords to enhance a website's search engine ranking. Sorry. Ranking from and boosting the organic traffic. Document summarization. So these involves summarization key ideas by extracting essential words and phrases from the context. And now we discuss about text classification. Sorts text into categories such as topics or emotions using keyword-based features. Now coming to the next slide, its conclusion. So how we conclude, like basically a keyword extraction explains its importance and diverse applications within the field of natural language processing and information retrieval and text mining. So keyword extraction is an automated technique for identifying and extracting key terms or phrases from a body of text. So this process simplifies and enhances several critical NLP tasks such as text classification, document summarization, information retrieval. So in conclusion, we generally summarize as keyword extraction is particularly valuable in applications like search engine optimization, managing large collection of documents, and drawing insights from textual data of business or research purposes. So this technique is foundational in knowledge discovery and decision making. And now coming to the next slide, references. So these are the following references for the keyword extraction. And thank you so much for giving this opportunity to present on keyword extraction.